4.6 billion years ago, Earth was not a planet, just a small disk of dust and rock floating around in space. But over billions of years, gravity caused this debris to clump together, forming our home planet and creating the conditions that allowed life to evolve, grow and eventually build giant towers 500 feet tall in the sky. Welcome to my channel. It's time to learn about Earth's history in just 10 minutes. In 10 million years, all the planets in the solar system formed from a gigantic cloud of dust and gas. But Earth was different. It was bombarded by huge space rocks. One particularly large one called Theia struck our young planet and knocked chunks of it into orbit. Over time, these pieces of debris settled down and merged to form a new, larger body. Some scientists think this is how the moon formed. Others aren't so sure. What they are sure of, however, is that at this point in Earth's history, it was nothing like the world we know today. The surface was mostly solid rock and metal. There were no oceans or atmosphere to speak of. In fact, Earth was a very quiet place. There were no birds tweeting or frogs croaking. You wouldn't even hear the wind blowing because there were no trees or leaves for it to rustle. Instead, volcanic eruptions were the main event. They shaped the land and released gases like carbon dioxide and water vapor into the air. As the planet cooled, these gases began to dissolve in the rainwater, turning Earth's early environment into a giant hot tub. 4 billion years ago, the water boiled away and Earth was once again a dry and lifeless planet. Then the rains came again, this time bringing with them organic molecules that fell from the sky in what scientists call a meteor shower. These microscopic building blocks of life included amino acids, which would later become the basis for proteins. Other ingredients for life, such as RNA and DNA, also rained down on Earth during this period. Eventually, the waters receded, leaving behind vast, shallow pools that became the cradle of life. 3.8 billion years ago, the first single-celled organisms appeared. They were simple creatures called prokaryotes without a nucleus or other membrane-bound organelles. They reproduced by simply splitting into two identical cells. This process is still used by some bacteria today. Life continued to evolve and diversify until 2.5 billion years ago when the oxygen level in the atmosphere rose dramatically. Scientists believe this increase, known as the Great Oxidation Event, was caused by the evolution of photosynthesis. As photosynthetic microbes like cyanobacteria grew in the shallow seas, they released oxygen as a byproduct. At first, this oxygen reacted with iron in the seawater, forming rusty deposits on the ocean floor. But as the oxygen levels continued to rise, the oceans became less and less reducing and more hospitable to aerobic organisms. And fortunately, this meant an end for many anaerobic prokaryotes. But more complex life was just beginning to emerge. 1.8 billion years ago, the first eukaryotes appeared. And like prokaryotes, they had a nucleus and other membrane-bound organelles. Eukaryotes also had access to a much more advanced form of cellular replication. This made them larger, more complex, and more capable than their prokaryotic predecessors. And yet, despite their greater complexity, they were still single-celled organisms. In fact, most eukaryotic cells are still only one cell thick. It wasn't until 1.2 billion years ago that multicellular organisms evolved. The first of these creatures lived in the ocean. They were little more than colonies of similar cells working together. Over the next 600 million years, however, they would develop into more familiar forms such as sponges, jellyfish, worms, and the ancestors of modern animals. During this time, Earth underwent another dramatic change. About 750 million years ago, the supercontinent Rodinia began to break apart. This marked the end of the Proterozoic and the beginning of the Paleozoic era, and with it came a whole host of changes that would shape the planet and its inhabitants. For example, sea levels rose significantly. This created vast inland seas that were cut off from the salty ocean water. As a result, they had low salt concentrations, making them more hospitable to life. Also during this period, the first ice sheets formed at the poles, leading to a global cooling. This climate change led to the evolution of the first hard-bodied animals. Their shells and skeletons were made out of calcium carbonate, the same stuff that makes up coral reefs and clams. And they help preserve the fossil record, giving us a window into the ancient world. 540 million years ago, the Paleozoic era kicked into high gear with the so-called Cambrian explosion. This was a relatively short period of time when most of the major animal phyla we see today first appeared. It was as if every type of creature imaginable just suddenly emerged onto the scene. But this explosion of diversity didn't happen overnight. It was the result of millions of years of evolutionary tinkering. During the Cambrian, animals like trilobites, mollusks, and echinoderms thrived. They ruled the seas for the next 100 million years until a massive extinction event wiped out 80% of all species. The cause was likely an asteroid impact. But whatever the reason, it cleared the way for new life to flourish. For example, the first fish appeared during the Ordovician period. They were small, soft-bodied creatures that probably didn't have jaws. But they were perfectly adapted to life in the water. Fish gave rise to a whole host of new species during the Silurian. They dominated the oceans while life on land began to diversify as well. Plants spread across the continents and the first forests appeared. But the Devonian was when things got really exciting. This was the age of the first sharks and the first tetrapods, four-footed vertebrates that would eventually give rise to amphibians, reptiles, birds, and mammals. But it was also the last period of the Paleozoic. Towards the end of the era, a mass extinction killed off around 70% of all species. The exact cause is unknown, but it may have been related to the breakup of the supercontinent Pangaea. At the start of the Mesozoic, there were fewer large animals on land and more in the sea. Marine reptiles like ichthyosaurs, pliosaurs, and mosasaurs dominated the oceans. Meanwhile, the first dinosaurs appeared, small, feathered creatures that would eventually grow to gigantic proportions. Birds also evolved during the Triassic, although early birds weren't very bird-like. They looked more like turkeys with wings. But over the next 65 million years, dinosaurs would become the dominant land animals. Some grew very large. The heaviest dinosaur ever discovered weighed over 11 tons. That's heavier than a Tyrannosaurus rex. But dinosaurs weren't the only ones getting bigger. During the Jurassic period, the first mammals evolved. They were tiny shrew-like creatures that scurried around the forest floor. Yet despite their small size, mammals would eventually give rise to giants of their own, including blue whales, which weigh over 200 tons, and elephants, which can reach 13 feet tall. Of course, we don't have any fossil evidence for this. The Mesozoic era saw the rise and fall of many other groups of animals, including the first true insects. But it was also marked by one of the greatest extinction events in Earth's history. Around 76% of all species disappeared at the end of the Cretaceous. The culprit was likely an asteroid impact, which may have triggered a chain reaction of ecological disasters, including a massive volcanic eruption in India. At the start of the Cenozoic era, it seemed as though mammals would take over the world. But they weren't alone. Birds also diversified, taking to the skies and evolving into all sorts of shapes and sizes. Early birds were small, but over time, some grew huge, developing enormous wingspans of up to 30 feet. But these giants didn't stick around for long. 56 million years ago, the Eocene epoch came to an end. The asteroid impact that caused it was so powerful that it left a permanent scar on the moon. But it was nothing compared to what came next. In just a few thousand years, the climate cooled, and the ice started to spread. It was the beginning of the Pleistocene epoch and the start of a dramatic transformation in the history of our planet. Large mammals known as megafauna flourished in the glacial north. They included woolly mammoths, saber-toothed cats, and giant ground sloths. Humans also evolved during this time. They migrated out of Africa and into Europe and Asia. They developed complex languages, invented new tools, and began hunting big game. And in the process, they may have played a role in the extinction of some megafauna. 20,000 years ago, the last ice age came to an end. It was the beginning of the Holocene epoch, which continues to this day. Many large mammals went extinct, but humans continued to spread across the globe. They built civilizations, developed agriculture, and eventually launched into outer space. Today, Humanity faces unprecedented challenges from climate change to nuclear war. But we've survived ice ages, asteroid impacts, and countless other disasters in the past. So maybe, just maybe, we'll be able to overcome whatever comes next.